Hello, my dear students. Welcome back to the lecture. So once we have arranged all this Excel sheet, up to here we have done, right? After that, we are supposed to make an Excel sheet something like this. I'm going to teach you all these things step by step, how it has to be done. So before that, quickly I'll explain you how the BBS has to be done for one footing. And once we understand that, only then we can prepare a Excel sheet, right? So that is the reason I'll take you to one of the BBS, which I've done it manually. If you know, it's well and good. If for someone who doesn't know that, I'll quickly give a recap of this, right? Yeah. So imagine I have a footing, okay? And the size of the footing is 2050 by 1850. This is my length and this is my breadth. And the depth of my footing is 400 mm. And this is a reinforcement what is given. That is along the shorter span, I'm supposed to provide a 12 diameter bar at 185 center to center spacing. And along the longer span, I need to provide a 12 diameter bar at 205 center to center spacing. So when I say center to center spacing, this is what it means, okay? So that, for example, if this is my shorter side, I'll quickly give you an idea. This is my longer side, okay? And this is my shorter side. So in the longer side, if I say center to center spacing, this is the center to center spacing along the longer side, okay? And when I say center to center spacing along the shorter span, so this is my shorter span, right? Isn't it? This is, I mean, yeah, I think I told other way around. Wait, yeah. So if it is longer span, then this is how it is, okay? This is the center to center distance between the longer span because this is the length what I have. This is the length what I have. Then I need to consider this as a longer span. So when it says center to center spacing, this is that spacing what we have. Okay, great. Okay, right. Now when I come to the shorter span, so this is the center to center spacing what I have. So this is my center to center spacing. Okay, so which diameter of a bar you are supposed to use? What should be the spacing? Those things it will mention in the drawing. Okay, same thing I'm going to teach you later once we start with the project for this. But to give you an idea, I'll show you once again here. So just concentrate here. If you see here, this is F1 footing. The length and breadth is given. The depth is also given. L1 in the bottom reinforcement. L in the sense along the longer span, you're supposed to provide a 10 diameter bar at 150 center to center spacing. Okay. To put it in a better way, I can do it in this way. Yeah. See, this looks good now. So this is what it is. Okay. Let us consider this is my length and this is my breadth. So along the length, what you're supposed to provide a 10 diameter bar at 150 center to center spacing. So all this reinforcement, whatever you have provided, no, longer span, this is 150, 150, 150, 150, 150. In this way, all the bars are placed around 150. In the same way, B1 is along the breadth. So this is my breadth, or let us say a shorter span. Okay. There also you are supposed to provide a 10 diameter bar and the spacing is 150. That means again, this spacing also, it is 150 here. This spacing along the shorter span, this spacing, whatever you can see, isn't it? This is also 150. So this is a practical application of that. And with the help of this drawing, we'll try to check how many bar you are supposed to provide, like 1, 2, 3, 4, 5. You can see, no, a lot of bars are there. We need to find how many bars will come along the longer span, how many bars will come along the shorter span, and what will be the total weight of steel that is required. So that is why the bar bending schedule has to be done. So I hope you have got an idea. And now the same thing I've written it here. So again, you see here, this is my longer span and this is my shorter span. So first we'll start with the shorter span. In the shorter span, I'll try to find what is the cutting length of my bar. Okay. So cutting length of the straight portion along the shorter span. So how do you find the cutting length? Whenever you find the cutting length along the shorter span, what we do, what is the length of your shorter span? It is 1850. You should not take the complete length. You need to take out the cover. You have to take out a 50 mm cover from this side and you need to take out 50 mm cover on the other side, right? So if you're not understood, just check here. See, this is a bar what we have provided, isn't it? So this is a bar what I have provided. See, this is a bar what I have provided. And a small L shape you can see here. Small L shape we are given here. So this is 1850 actually. Practically, this outer to this outer is 1850. I'll write it here. This is 1850 for me. Okay, great. But whenever you put the bar, no, you don't put it completely from this end to this end. We give a cover. You can see this is called as cover block. If you've taken my basic course, you know that. So this is called as cover block. So for the footing, I'm going to leave 50 mm from the left side, 50 mm from the right side. So out of 1850, if I take out or if I deduct 50 out, 50 from the left side and 50 from the right side, what is left out? 1850 minus 50 will be 1750. So this length, whatever I'm going to get, no, this length from here to here, it will be 1750. You're getting my point. So this is how you're supposed to calculate it. Okay, great. So having said that, I've done the same thing here. So just check here, 1850 minus 50 on the left side, minus 50 on the right side. So which comes out to be 1750. Now you may ask me one question. So why it is 50 mm? See, there are certain rules or there are certain standards which we need to follow. For the footing, we take cover as 50 mm. That is why I taken. Now, is it that every time it will be 50 mm? Most of the cases it is 50 mm. There are certain cases in case of raft foundation, we are supposed to take this as 75 mm. So all these things depends on the project specific. But 90% of the cases, if it is a normal isolated footing and all, usually 50 mm is what we take. But sometimes it will be written in a structural drawing what kind of cover you are supposed to take. If it is mentioned, if it is a rough foundation and you are supposed to take out 75, in that case, instead of 50, we'll deduct 75 here on both the side. Getting my point? But here, since it's isolated footing, what we have, I'm going with 50 mm. Got it? Coming to the column and all, I'll take it in a column section, not here. Okay. Now we found only the this length, isn't it? Agree with me? Only this length I have found. What about this length, and this length? What? How much we are supposed to take, right? So that also we need to find. Like this length we are supposed to take. No, if I show it here, this length, this L shape you can see, this bend and this bend. That we didn't calculate because we calculated only the bottom straight portion. So what will be this and this side? So for that, again, what you need to do, will come here. Usually this depth will be given, right? What is the depth of your foundation? It is 400 mm. So what we try to do, we usually deduct the top and the bottom cover. What we do, whatever is the depth of my footing, like if this is my depth of my footing, okay? See, this length I want, no, this is my depth of footing. So it is mentioned 400 mm. The depth of footing is 400 mm. So what we try to do in this 400, we'll take out the top cover and we'll deduct the bottom cover. You can see in this bottom, you can see, no, it is 50 mm. This side is 50 mm. Okay. So from the bottom 50 mm we'll deduct, and from the top 50 mm we are going to deduct. Okay. So 400 minus 50 is 300 mm. So what we have done here, I've written 300 mm. See, development length is 300 mm. Okay. That is one way of doing. In some of the cases, what people do is that they directly give you in the structural drawing. Like example, if I go back to the drawing now, yeah. Hmm. So if I go back to the drawing, so see, this is the typical, okay. So in some of the cases, whatever length we have here, no, this length you can see, people will measure this. I mean, a structural consultant, usually sometimes he is going to give, like you can take directly 12 inches or 300 mm. In that case, we'll directly consider this. If it is not given, in that case, what we are supposed to do, in that case, we'll take the overall depth of the foundation. And from there, we'll deduct the bottom cover, which is 50 mm, and we'll deduct the top cover, which is 50 mm. So in that case, this particular thing will come somewhere here. Now, there are few other people, what they do, they I'll tell you one more method. See, now this bar bending schedule, you don't have any fixed method. It depends on the company where you're working. It depends on what procedure you're adopting. I'm explaining everything. Tomorrow, when you start to work, if your company is following this, then you can go ahead with this. What few people do, overall depth is 400 minus top 50 minus bottom 50. How much answer you got? You got 300 mm. Now, for this 300 mm, they'll multiply by 75%, or they'll say 2/3 of this depth we are considering, 2/3. Okay. So that also few people do. That is 2/3 is 0.7, 0.67. 67% they are going to consider. So you can do that also. That means 300 into 0.67. So I'm getting 201. I'm getting 201 mm. So this height, whatever we got, no, this height we got, no, this will be 201 mm. So few people follow this also at the side. It's totally depend on what you people are following in your side. Okay, you can follow any method which you have given. Okay, but most of the people follow the same method. That is, whatever top cover minus cover, and 2/3 of that they are going to do. And same thing in the Excel sheet also, I've done the same thing. If you see here, I've taken 2/3. I'll explain you later. Okay, but this is a normal construction practice what we do. Few people don't add 2/3, and they directly deduct the top cover and the bottom cover. Okay, so it totally depends on the company that you're working for. Okay, great. So now what I've done in this calculation, I haven't done in that way. I've directly taken 300 mm, but I'm showing you all the cases. Okay, great. Now, if I get the development length, this one side it is 300, here also it is 300, and this length already I have found. So the total cutting length will be 1750, that is this straight length 1750 plus this 300 plus this 300. So 1750 plus 300 plus 300. So which will be 2350 mm. Got it? So this complete cutting length of one bar is 2350. So I have found the cutting length for one bar. But how many bars are there, that I don't know, right? If you see here, there are so many bars like 1, 2, 3, 4, 5. I don't know how many bars are there. How do you find the number of bar? So always remember, whenever you're supposed to find the number of bar, the shorter side number of bar will be always you have to take the opposite side. If I'm taking shorter side, it has to be longer side minus two sides the cover, divide by the shorter span spacing plus 1. Okay. So this you have to remember this formula. If I'm finding a shorter span, I need to take the opposite, that is a longer side. Suppose if I was finding the longer span in further slides, I'll show you that. See here I'm taking a longer side. In that case, the formula will be shorter side minus two side the cover, divide by longer span spacing plus 1. Okay, you just have to remember this, and then it is very easy. So the shorter side number of bar will be, what is the longer side? So this longer side is 2050. This is 2050 minus two sides the cover. Again, here also I need to deduct 50 mm. From here also I need to deduct 50 mm. 2050 minus 50 you do, and that you divide by shorter span spacing. So shorter span spacing, it's given 185 center to center spacing. That is the distance between these two bars is 185, 185, 185. So I'm dividing this by 185. Try to do it manually. How much you are going to get? So it will be 2050 minus 50 minus 50. 1950. So 1950 you divide it by 185. I'm getting 10.54. So how much I'm getting? 10.54. So since it is 10.54, I can consider this as 11. And always we need to add plus 1 to that. So it will be 12 numbers. Why plus 1? Because right now, whatever we are considering, no, it is a spacing. See, this is 1 bar, this is 2 bar. But in between this 2 bar, we consider this as spacing. But how many bar are there? 1 and 2, isn't it? So that is why whenever you find the number of bar, always you have to add 1 in the bar bending schedule. Not only in the footing, further when we do the beam, the column and all. So always in the stirrup and all, we have to add 1. This you have to remember forever. Okay. And what is the reason behind that? The reason is, see, bar is how much? 1 bar. I'll show it here only. See, how many spacings are there? 1 spacing, 2 spacing, 3 spacing, 4 spacing. I'll do it in this way. Okay. See, 1 spacing, right? 2 spacing, 3 spacing, 4 spacing. Okay, I'll do it in a better way. Because what happens is, after some time people ask me the same doubt. So that is why let me make it clear. This is 1 spacing. This is 2 spacing. This is spacing number 3, spacing number 4, spacing number 5, and spacing number 6, right? Spacing is 6. But when you're finding the number of bar, count how many bars are there. This is 1, no? This is 2, no? 3, 4, 5, 6, and 7. So that is why spacing you had 6, but number of bars are 7. So that is why whenever you find the number of bar, always add plus 1, right? So that is why I've written plus 1 here. So if I do that, I'll get 12 number of bar. So shorter side 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bars I'm going to put. So practically I'll be putting in this way 1, 2, 3, 4, 5. Okay, in this way, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bars I'll put only on the shorter side. The longer side I didn't calculate. For the longer side, again, I'll start with the longer side now. So the cutting length of the straight portion along the longer span now. What is the span we have? 2050, isn't it? So the longer span is 2050, but we know that this length, if I want, what I need to do? Overall length 2050 minus 50 from the right side, minus 50 from the left side. So 2050 minus 50 and minus 50. How much it comes out to be? 1950 mm. Fine. Now, this I don't know. This is development length. This is also development length. So development length, I'm considering here 300 mm by default for our understanding. But when I take the real projects, we'll apply the concepts and I'll teach you. Always remember this, whatever we have, it totally depends. Okay. 300, how did I get? Because overall depth is 400 minus top 50 mm minus bottom 50 mm. So 400 minus 50 will be 300 mm. Okay, great. Now the total cutting length, can you find? Obviously, this length, this length is 1950 plus this is 300 mm plus this is 300 mm. So 1950 plus 300 is 2550. So this is a total cutting length of one bar, which is 2550. But how many bars are there? That I don't know. So therefore, the longer side number of bars will be always longer side I took. So your formula will be opposite side, that is shorter span. So longer span, if I want to find, I need to take the shorter span minus two sides the cover, divide by longer span spacing plus 1. So what is the shorter span? Shorter span is 1850. This is 1850. So 1850 minus 50, because this 50, see, I'll explain you why this minus has to be done, but now understand it. Minus 50, and you do this, you'll get 1750 divided by longer span spacing. So longer span spacing is 205. So divided by 205. Let me do that. How much answer you're getting? So it will be 1750 divided by 205. I'm getting 8.53, which I can consider it as 9 number. So 9 plus 1 will be 10 number. Got it? So in this way, you're supposed to do the bar bending schedule. Now you may ask me one question. When you're finding the longer side bar, you're taken shorter span. I agree, sir. But why you have done two side cover? Again, for a very same reason. See, this 1850 is from outer of this footing to outer of this footing. But when you're placing the bar, is your bar exactly at the outer? No. From outer, you are left 50 mm cover. From here also, you are left 50 mm cover. That is why shorter span, that is overall length, minus 50 from this side, minus from 50 from this side. Okay. To put it in a better way, you get an idea here. I'll show you here. See here. Okay. This one. When you're calculating this overall length, minus 50 from here, minus 50 from here. That means, see, if I want to find how many bars are there, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need to find how many bars are there. If I want to find this bar, which length I'm supposed to take? I'm supposed to take this length, okay, from this outer to this outer. So let us consider this outer to outer length is 1850. It is 1850. So 1850 overall length, outer to outer, minus from here you have to leave 50 mm, and from here you have to leave 50 mm. See, this first bar, whatever you are placing, no, is it that it is exactly at the outside of the footing? No, we are left a 50 mm cover. In the same way, this last bar, whatever you can see, is it exactly at the outer of the footing? No, you are left a 50 mm gap from here. So that is why in the formula, always remember this formula. See here also, shorter span minus two sides of cover. Okay, that's it. So once you find this, you will get the number of bar. And if you multiply this by the unit weight, what is that unit weight? We are written, if it is 8 mm bar, you have to multiply this by 0.395. If it is 10 mm bar, you are supposed to take 0.617. So in this way, if I multiply, I'll get the total weight of the bar that is required. Got it? So I hope you have understood the concept here, how it has to be done. And in the next lecture, I'll teach you how this Excel sheets has to be done. Previously, we have done up to here, right? Now, after that, I'll teach you how this Excel sheets has to be prepared and how we can input all these things. Now, one doubt may come in your mind. Sir, we have seen in many videos and all that people take this thing, bend deduction. So what is that bend deduction? Bend deduction means, see, this is a straight bar what we have. But when we bend a bar in this way, this is my 90-degree bend, right? So this angle what it is created, is 90-degree. This is 90-degree. So whenever you are bending a bar, what will happen? Here, there will be increase in the length of your bar. So according to the code, it is written, if you're bending your bar in 90-degree, you have to take 2 times the 2D deduction, 2 times the diameter of a bar you have to deduct from the overall cutting length. Suppose if you're bending your bar in 135-degree, you have to take 3D deduction, 3 times the diameter you're supposed to deduct. Suppose if you're going for 180, you're supposed to take 4 times the deduction of the bar. And suppose if it is a 45-degree, it is 1D. Suppose if you're bending your bar in 45-degree, it has to be 1D. Okay. So according to this logic, you can see this is a cutting length what we got, 2550. This cutting length what we got is 2550. But since I have 190-degree bend here, I have another 90-degree bend here. So how many bends we have 90-degree? 1 and 2. So 2 bends we have, right? So two 90-degree bends we have. And according to the logic, according to the logic, if you have 190-degree bend, you have to take 2 times the deduction you have to take. So that means, according to my calculation, how many bends I have? 2 I have. So 2 into how many deduction if it is 90-degree? 1. We have 2, no? So 2 into 2D I'm supposed to do. So 2D means it becomes 4D. And what is the D is the diameter of the bar. So what is the diameter of the bar given? Here it is 12 diameter given. So that will be 4 into 12, which comes out to be 12, 20, 48 mm. So whatever cutting length I got, no, 2550. So 2550 minus 48 I'm supposed to do. If I do this, no, this will be the actual cutting length of my rebar. That is 2550 minus 48, which is 2502 mm. But I didn't do this because, see, now again the same thing. Few companies follow this, few companies don't follow this. Okay, so it's totally up to your company which what you follow. But I thought you both the example. If you want to add the bend deduction, you have 2D bend, so minus that 4D from the cutting length you have got. If you don't want to do that, keep it as it is, not a problem. Okay, so all these things will be discussed at the time of the project only, because when you're taking up a project nowadays, what is happening, most of the contractors and most of the clients, they say in the beginning itself that we'll not do this bend deduction, and based on that we carry out the bar bending schedule. Okay, now there are few people who say no, we don't follow that, we want to add the bend deduction. If that is the case, then you add the bend deduction. Okay, so in all my thing, in all my Excel sheet, whatever I taught you, I haven't taken this bend deduction, but I'll teach you how a bend deduction has to be applied, not an issue. But you should be knowing everything. Okay, because what happens tomorrow, you should not tell that I did not teach you. So it all depends on the company that you're working for. Few people follow that, few people don't follow that. Like I always give example. See, when we do any design of a structure, okay, when we do any design of a structure, let us consider if this is my beam, okay, and on this beam, we did a calculation, and let us consider this is a uniformly distributed load which is coming on the beam, and we did a calculation, and we found that the uniformly distributed load is 11.73 kilonewton. Okay, so but 11.73 doesn't look good. You can take it as 12 kilonewton. Now what happens? Few people add 11.73 only. What few people do? They add 12 kilonewton. And even there are few people who say even though it is 11.73, in real structure this much load will not come. Instead of 11.73, we'll make it as 11.5. Now you tell me who are wrong. No one is wrong in this. It's totally their judgment what they are doing, and they have been following this. So the person adding 11.73, he is also correct. The person who is adding a live load, or let us say UDL of 11.75 kilonewton, he is also correct. And the person who is adding 12, he is also correct, right? So there is no one is wrong. So these are the different theories, or these are the different principles. We always call this as two school of thoughts. So it totally depends on you. Okay, now no one is wrong. In the same way, when I'm explaining you this bend deduction, it is also same thing. Few people follow that, few people don't follow that. So I've explained you both the method, and both are correct, right? Yeah. So I hope you have enjoyed my lecture up to here. So in the next lecture, I'll teach you how this Excel sheets has to be prepared, and then we'll go on inputting the values, and we'll try to see how the Excel sheet linking has to be done. So we'll see you back in the next lecture. Thank you.